Okay, we have two simple simultaneous equations. This one we notice has a plus y and a minus y, so we know that we can use adding. This one has a plus y and a plus y, so we can use subtraction in this method. Okay, let's look at how to do them. They're nice and simple. We don't have to multiply any of them by, we don't have to multiply one to get the same number, because here we have a plus y and here we have a minus y. And if we just think of them as being in separate columns, here are all the x's by themselves, here are all the y's by themselves, and here are all the numbers by themselves. And remember, when we're adding and subtracting, we only add x's to x's, so that's why this method works. So we just put a big line under here and we add all our x's together. 3x plus, big plus sign here, big plus sign here. 3x plus x is 4x. Y plus minus y is 0, so it's gone. So we know that 4x equals 13 plus minus 5 is the same as 13 minus 5, which is 8. So we know that 4 lots of x equals 8, and we've got rid of our y, which is what we want. So if we know that 4 times x equals 8, to get x by itself, we divide both sides of our equation by 4. 4 divided by 4 gives us what 1x is. So 1x is 8 divided by 4, which is 2. So we know that x equals 2. Now we know what x equals. We put x equals 2 into any of those two equations. It doesn't matter which one. Let's put it into 1. 2 minus, into equation 2. Call this one equation 1 and this one equation 2. Put x into equation 2. I'm explaining what I'm doing each step of the way. 2 minus y equals minus 5, because I know that x equals 2. 2 minus something is going to give me minus 5. Well, then y would equal 2 plus 5 would equal y. I change the minus 5 to the other side, it becomes a plus. I change the minus y to the other side and it becomes plus y. So we get that y equals 7. If you're not familiar with doing that in 2 steps, you can do it in one step like that. You can do it in 2 steps. At first we add y to both sides of the equation. That would get rid of the y. If I add y to this side, I must add it to the other as well. So here I would get 0. I'd get minus 2 equals minus 5, plus 2 equals minus 5 plus y. So y, add 5 to both sides of the equation here. 7 would equal y. Y equals 7. Let's check that we've got it right by putting it into our last equation. 2 times 3 would be 6, plus 7, we know that y is 7 now. 6 plus 7 equals 13. Yes, it does. So we're right. So we always have the check afterwards. Okay, what do we do here then? We've got another simultaneous equation. We have a plus y here and a plus y here, so we can't add them, because if we added those together, we get 5x plus 2y equals 20. It's not going to help us. We've still got 2 equations, 2 unknowns. To get rid of the y here, we could minus and do a big subtraction to each of our columns here. 2x minus 3x would give us minus x. Y minus y would give us 0. And 9 minus 11 would give us minus 2. If minus x is minus 2, divide both sides of our equation by minus 1, we'd get that x equals 2. So we now know that x equals 2. Let's put it into equation 1. X equals 2 into equation 1. We'd get that 2 times x is 2, 2 times 2, plus y equals 9. It'd get 4 plus y equals 9. Y must equal 5. 4 plus 5 equals 9. Y equals 9 minus 4 equals 5. We now know that y is 5 and we know that x is 2. We do our final check by putting it into equation 2. 3 times 2, because x equals 2, plus 5. That would be 6 plus 5. Does it equal 11? Yes. So we have our final check to show that what we've done has worked. And this is simultaneous equations solving two equations with two unknowns.